Today we will be doing multiple linear regression. Right, in previous session we covered simple linear regression. Okay, so the difference between simple linear regression and multiple linear regression is if there is one independent variable, then it is the candidate for simple linear regression. Okay, and if there are multiple independent variables, like in this case, if you see, we have one dependent variable profit and 1 2 3 4, right? So four independent variables. Okay, so if there are more than one independent variables, okay, then the data set is candidate for multiple linear regression, right? So here we have this multiple linear regression data set, and let's get straight into it. So here we have 5 columns, but the real interesting thing about this data set is that this is like a very realistic business challenge. So here we have 50 companies in total. So 50 companies data, okay, we have in this data set. And what they have is they have some extracts from their profit and loss statements, okay, from their income report. So we have this profit column, right? And we have R&D spend, administration, marketing spend, and state columns, state fields, right? So, and what they have is they have some this details, profit details, okay, from their income report. So how much the company, okay, in this given financial year, okay, this data is actually of a particular financial year, right? So how much the company in this given financial year that we are analyzing for, okay, how much in that year it spends on this R&D, the research and development, how much the company spent on administration, like paying employees, okay, paying executives and so on, and how much it spent on marketing. Okay, this is marketing spend. So these are the three major operational spends, I guess. Okay, R&D, administration, and marketing. And which state, okay, it operates in, it works in. And finally, the profit. What was the profit of that company, okay, for that financial year? And the challenge here is that this data set is totally anonymous. We don't have company names, okay, in this data. Okay, this data set has 50 companies data, but we don't have company names, okay, in this data set. So we don't know the companies, and there is only 50 companies. So there is a venture capitalist fund, right, that has hired you as a data scientist to analyze these 50 companies data set and create a model that will tell the venture capitalist fund which types of companies it should be most interested in, okay, in investing. And their main criteria is the profit, right? This output, this profit. So profit is the dependent variable. The most important variable is this variable, okay, for them, the profit. And R&D spend, administration, marketing spend, and state, okay, are all independent variables, right? It means these are predictors. So these variables, these features will be used to predict profit, right? So we have to create a model which will tell us about the profit based on R&D spend and the state. And bear in mind that the venture capital fund is not looking to invest in these 50 companies per se, right? So what they are looking for is this is a sample, and they want to understand, for instance, where companies perform better, right? In New York, California, Florida, right? So will a company that spends more on marketing perform better, or a company that spends less on marketing? Okay, so this company, okay, wants to know. So do they look for companies to spend more on research and development, or to spend more on marketing? Right. So that company wants to understand whether these companies should spend more on R&D or administration, right? To make more profit, right? So which of these two spends yields better results? R&D spend or this marketing, right? We have actually R&D spend, okay, which we can control, and the marketing spend, right? So which of these two spends yields better results of profit? And based on that, our model that we will create, okay, they will have a set of guidelines for their own venture capitalist fund, that and they will be like, okay, so we are more interested in companies, okay, this is just an example, okay, that operate in New York, okay, and that have a very low administration spend, right, and a very high R&D spend, and the R&D spend has to be much higher than administration and marketing spend, something like that, right? So basically you are helping them create a model, okay, based on this data set, okay, that will allow them to assess where and into which companies they want to invest, or they should invest to achieve their goal of maximizing the profit, right? So let's go back to the Jupyter Notebook and implement this. So let's understand the equation for multiple linear regression first. Okay, so the equation for multiple linear regression is y equals to this. This is y hat actually. Okay, the predicted value. So y equals to b0 plus b1 x1 plus b2 x2, okay, and you can add more pairs, okay, to it, bn xn, right? So where y is this is dependent variable, and b0, this b0 is a constant, this is y intercept, okay, this is y intercept, and b1 is, this is slope coefficient, first slope coefficient, slope coefficient 1, and x1 is independent variable 1, okay, and then we have more pairs of slope coefficient and independent variables, right? So basically we have as many slope coefficients as we have independent variables, okay, in our data. And this is the whole structure of the implementation, okay, importing the libraries, importing the data set, encoding categorical data, splitting the data set into the training set and test set, training the multiple linear regression model on the training set, predicting the test set results, okay. So this is the whole structure of the implementation, okay, that we are going to implement, right? So here first first tool, the first step is importing the libraries. Add a new cell and import numpy, pandas, matplotlib, pyplot, okay. So import numpy as np, import pandas as pd, and import matplotlib.pyplot as plt. So we are importing, okay, 3 libraries. Run this cell. So cell executed successfully. Now step 2 is importing the dataset. Add a new cell. Okay, we will be importing the data that I showed you. Dataset file name is startup underscore data.csv. Okay, so pd dot read csv, and I have that file in data folder. File name is startup underscore data.csv, and assign this to dataset. Okay, run this cell. Okay, so data has been loaded successfully. Okay, now we have this data set. So to verify the data has been loaded successfully, okay, you can use dataset.head. Okay, it will show us what? It will show us top 5 records. Run this cell, and we have R&D spend, administration, marketing spend, state, and profit. Okay. Next step is extract matrix of features and dependent variable vector, right? So from this data, okay, we will separate out these 4 columns because these are independent variables. Okay, and this profit is that dependent variable, right? So add a new cell, add one more cell, x equals to, okay, so to extract matrix of features, x equals to dataset dot ilog. Now we want to take out all rows, all columns except the last one, dot values, and y equals to, copy this, and we want to take out only the last column, all rows and last column. Okay, this profit columns data. So all rows -1, run this cell, and then let's print x and y. Print x, and we have this data, okay, in x, and if you see here we have R&D spend, this is administration, this is marketing spend, and this is state, right? We don't have profit, okay, in this data. And then add one more cell, print y, run this up, and we have this vector, okay, values from that profit column. Okay, so now we have data in x and y. Next step is encoding categorical data, okay, because here if you see we have no numerical data, right? So we have state names, New York, California, Florida, right? And if you remember, okay, we have discussed that, okay, if you are preparing data for model training, okay, then all data should be, or all features should be, okay, numeric features, numeric data, right? This is non-numeric. So here it requires what? It requires encoding, because this is categorical feature, right? So this, it needs to be encoded. Add a new cell, and here, if you remember, in last session, okay, we used one hot encoder, right? In last session, okay, when we discussed data pre-processing, okay, we discussed one hot encoder. So here, from scikit-learn dot compose, import column transformer. Okay, so we will be creating one transformer, okay, based on encoder, and import from scikit-learn dot preprocessing import one hot encoder, right? So let's create an object of instance of column transformer, create an instance of column transformer. So ct equals to column transformer. Here we need to specify, we need to pass actually transformers, okay, and this needs to be set to a list, and within parentheses, okay, we can specify what? The name for the encoder. So let's name it encoder. Okay, you can give it any name. And here we want to use one hot encoder. Okay, and third parameter is the column, okay, that needs to be encoded. So here, if you see here in this data, 0, 1, 2, 3. So state is the fourth column, index 3, right? So here we can specify 3. Okay, we want this column, okay, to be encoded. And then we can specify remainder. Set remainder to pass through. Okay, otherwise, what will happen? Okay, the columns, okay, which will not participate in this encoding process, okay, will not be returned. Okay, so we want all other columns, okay, to be returned. So here we can say pass through, right? And then ct dot fit transform, call fit transform, and pass x, right? So here this fit transform, it will actually calculate the data which is required, okay, and then it will actually encode the column, right? So use fit transform, and to convert the result into numpy array, okay, you can use np dot array, because we need a numpy array, right, for model training. So let's set it to x. Okay, so in this statement we are creating a transformer, okay, and here we are passing a name, here we are creating an instance of one hot encoder, okay, and here we are specifying which columns is categorical column which needs encoding, okay. And here, by setting this remainder to pass through, we are saying that, okay, pass the columns, okay, which are not being encoded, pass the columns, okay, which are not being processed also. Run this cell. Okay, so now add one more cell and print x. Print x. Run this cell. And if you see here, now we don't have this column. Okay, this state column values here. Okay, we don't have state column values here. Now we have, because here in our data, okay, we have New York, California, Florida. Okay, here we have, okay, 3 columns, right? So binary columns. Now all values are now numeric values, right? Now we don't have non-numeric values in this data. So we are done with this step. Next step is splitting the data set into the training set and test set. Okay, so in this step, we will be splitting this data set, okay, into two sets, training set and test set. Training set we will use to train the model, and test set we can use to evaluate the model, to test the model, right? So here, okay, so here, first of all, import one package, right? So that is train test split. So you can import that package from model selection. So from scikit-learn dot model selection import train test split. Okay, and call this function train test split function, pass matrix of features as first parameter and y as second parameter. Then specify test size 20%, 0.2. Okay, so we want the test size to be 20%. It means 20% records to be in the test set. And random state, set random state to any number. Okay, if you want the split, okay, reproducible split. Okay, reproducible split means if you want the split to happen, okay, or same set of records to be there in training set and test set, okay, in that case, okay, you can use a number, right? If you use same number, okay, then the result will be reproducible. And then assign sets, okay, assign that 4 sets, okay, to 4 variables. So first variable is xtrain, second variable is xtest, ytrain and ytest. Okay, run this cell and now add 4 cells, okay, to print all 4 variables xtrain, xtest, ytrain, ytest. Add 4 cells. Print xtrain, print xtest, ytrain and ytest. Okay, run all cells one by one. So here we have this data, okay, in xtrain. We will be using this data to train the model. Xtest, we will be using this data to test the model. Okay, ytrain and ytest. Right, so now we have after splitting, okay, data in 4 variables, right? Next step is training the multiple linear regression model on the training set. Okay, because now we have this data. okay, which is ready to train a model, multiple regression model. Why multiple? Because we have multiple variables, more than one variables, okay, in this matrix of features. Now, to train the model, first of all, import a package, okay, from scikit-learn dot linear model. Import linear regression, okay, and then create an instance of linear regression, and let's use a variable regressor equals to, okay, and next statement, train this model. To train this model, okay, call regressor dot fit, call fit method, okay, to train the model. And to train this model, okay, use x train, okay, the set that we actually separated out, okay, for training this model, and the y train, okay. Now run this cell. Linear regression model has been created, right, based on x train and y train, right, training data set. And then we can use this model, okay, to predict results. So if you want to predict test set results, because we already have this y test, right, we already have this y test, so we already have actual values, actual results, and this model has not seen, okay, this x test, right, we actually separated out, okay, before using this data, okay, for training the model. So now here, okay, we can use this model to predict test set results. So regressor dot predict, okay, use predict function, and we want to predict test set result. So x test, okay, and assign result to a variable. So let's name it y predicted, y predicted. Run this cell. And now we have predicted values in y pred. We have real values in y test, right? So now we can compare predicted values with real values, okay, to check how accurate, okay, our model is. So let's add a cell here. Okay, first of all, let's print y pred. Print y pred, and if you see, these are the predicted values, and these are actual values, okay, real values. Let's write a statement, okay, to print these values side by side, okay, so that we can compare, okay, them easily. So here what we can do is we can use np.concatenate, np.concatenate, okay, to concatenate values from, okay, two variables, and then let's print y pred, and reshape it. I'll tell you what is the need of, okay, reshaping this data. Reshape length of y pred, okay, and one column, Okay, so it will actually reshape it. So it will create this by this array. And then y test. Okay, the value of, next we want to print values of y test dot reshape length of y test. Okay, and 1. Okay, and here we can print 1 and then use print function, right? And before doing this, we can do one more thing. We can set precision, okay, for that numpy. np dot set print options. Precision, set it to 2. Okay, because we want only 2 numbers, okay, to be printed, okay, to be displayed after decimal. Run the cell, and if you see now these values, okay, these are actually the predicted values. Okay, 1,26,362 and 84,608. Okay, these are predicted values and these are actual values. If you see here, this is 1,34,307, right? And the last value is 1,22,776. This is the last value, right? Okay, now we can compare these values. So if you see, this is 1,26,362 and this is 1,34,000. This is actual value. Okay, 84,608, 81,005, 99,677, 99,937. Okay, so these are real values, actual values, and these are predicted values. Okay, and if you see here, these predicted values are close to these real values, right? So our model is working fine. So that's all for what is multiple linear regression and how to implement it. Okay, thank you for joining and see you in the next session.